Last time we were talking about source coding, and the last, we proved several results, but the last thing that we proved, based on the Kraft inequality, was that the average length for a code was at least entropy. The average length for a prefix code, that is. So remember what a prefix code was. A prefix code is a code where no code word is a prefix of any other code word. And what I mean by prefix is that, well, here's an example. Here's one code. Here's another one. This code is a prefix code because no code word starts with, except this one starts with 0. No code word other than this one starts with 1, 0, and no code word other than this one starts with 1, 1. This is not a prefix code because this code word is 0, and this code word starts with 0. So 0, this code word is a prefix of this code word. So this is not a prefix code. So prefix codes are nice because they have the property that you can instantaneously decode them. In other words, as you see code words, you can immediately decode them. So we also saw that h of x is achievable. Under the condition that the probability density function p of x is equal to 2 to the minus lx, where L of x are code word lengths. So one example of this, let's say my encoding alphabet U is equal to A, B, C, D, and the probabilities of these letters, probability of A is, let's say, 1/2, probability of B is, let's say, 1/4, probability of C is, let's say, 1/8, and probability of D is, let's say, 1/8. Then this is this probability distribution, this source satisfies this property because we can set L of A to be 1. In other words, we use 1 bit to encode A. We use 2 bits to encode B, because 1/4 is 2 to the minus 2. And we use 3 bits to encode C and D. So this is a valid probability distribution. If we add this up, 1/2 plus 1/4 is 3/4, plus 1/8 is 7/8, plus an additional 8 is 8/8, or 1. And these lengths satisfy this property. So we could easily see that. Firstly, what's the entropy of this source? The entropy of this source is 1/2 log 1/1/2 plus 1/4 log 1/1/4 plus 2 times 1/8 times log 1/1/8. This is 1/2 log 1, which is, let me continue this over here. So that's 1/2 log 1, which is 1/2, plus 1/4 log, 1/2 log 2, which is 1/2 times 1. 1/4 log 4, what's log 4? is 2, 2 over 4 is 1/2, and 2 times 1/8 times, what's the log 8? Is 3. So that would be 3/8 times 2, which is 6/8. So I get 1 3/4. And we can see that L of C is equal to h of x because the length of this code word is, it satisfies this. If I want to get the lengths, I can just take the log of both sides here, and I end up with negative log p of x is equal to L of x, and that's exactly this, this, and this. So therefore L of C also equals 1 3/4. So in this particular instance, because the probabilities all have this property of being negative powers of 2, that is the circumstance in which equality is achieved here, and so therefore this code can achieve the entropy. Now, can we write down a prefix code?
Sorry.
Yes.
I'm lost in the word. What did you compare with what? I wasn't paying attention. What's the equality you showed?
I'm comparing LC and HX.
The equality case?
Yes. Okay. So this is HX, and all I'm arguing is that if I want L of C, then I basically, the log is substituted for the length, but they're equal. This log is substituted with that length. This log is substituted with these lengths, and they're equal. So therefore L of C is 1 3/4, and h of x is 1 3/4. So can we write down a prefix code for this? A, B, C, D. So here's X and the code. So A, I need a code word of length 1. Let's pick 0. B, I need a code word of length 2. Any suggestions? 1 0. So that's okay because 1. 0 is not a prefix of this one, so that's fine. For 3, I can do 1 1 0. 0 is not a prefix of this. 1 0 is not a prefix of this. And I need one more of length 3. 1 1 1. So again, 0 is not a prefix of this. 1 0 is not a prefix of this. 1 1 0 is not a prefix of this. So this would be a source code that achieves the entropy of this source. Okay, now, it's extremely rare that sources have probabilities arranged just so, like this.